Back to our general awareness course on the transportation of dangerous goods regulations. In this module, we will discuss classifying dangerous goods and using Schedule 1. I want to start off this module with a question. What are some of the TDG classifications? For those of you who are stuck, think of WHMIS. The TDG classes are very similar to WHMIS ones. As shown, there are 9 TDG classes. Class 1 explosives, Class 2 gases, Class 3 flammable liquids, Class 4 flammable solids, Class 5 oxidizers, Class 6 poisons, Class 7 radioactive dangerous goods, Class 8 corrosives, and then Class 9 miscellaneous dangerous goods, which basically becomes marine pollutants. But how does a product become a dangerous good? Well, there are 2 ways. First, the regulations include technical definitions for all the classes. For instance, a flammable gas is defined as a gas that, at 20 degrees Celsius and normal pressure, will ignite when the concentration is 13% or less, or has a flammability range of at least 12 percentage points. If a product meets either of these criteria, it is a dangerous good of class 2.1. These criteria are discussed in detail in our Transportation of Dangerous Goods classification course. The second way for a product to become a dangerous good is to be listed in Schedule 1. So what is Schedule 1? Despite its unassuming name, Schedule 1 is the heart of the regulations. At 280 pages long, it lists most dangerous goods given their official name, UN number, limits on transporting, and much more. Products in Schedule 1 are sorted by UN number. This is an excerpt from Schedule 1. In addition to Schedule 1, there is Schedule 3. This schedule has some of the same information from Schedule 1. However, it is listed in alphabetical order. This allows you to find the UN number and then use Schedule 1 to get more details. So when would you use which schedule? Let's take an example. Assume you want TDG information about car batteries. Using Schedule 1, you could start at the beginning and go down the list until you find batteries, 97 pages later. Or perhaps you do a search for batteries and you have 145 entries to go through. Or you turn to Schedule 3 and look up batter. You don't even need the whole word. And there you go, all in one place. Check the UN number, and then go look the car battery up directly in Schedule 1 to get the full details. And there we go. Car batteries. The official name, batteries wet filled with acid. Now that we know how to find something in Schedule 1, I want to discuss what information you can get from there. The first column is the UN number. This is the number we are all familiar with, seeing it on tanker trucks and other vehicles. As the name suggests, it is assigned by the United Nations, specifically in their model regulations. But the products all have names. Why do we need a number? I will illustrate why with a simple example. Look up at the word on the screen. Is that product dangerous? That's a bit of a complicated word. Let's simplify it with this one. No takers? Well, let's use a more recognizable alphabet. Still a mystery? Well, now this is the ultimate clue. Yes, these are all words for arsenic, specifically in Hindi, Chinese, Russian, and Italian. So what do all these words have in common? They have the same UN number, UN 1558. The number is common in all countries. That way, given a universal number, one does not need to speak Russian to know that a shipment from Russia with UN 1558 on it contains arsenic. The second column of Schedule 1 is the shipping name. This is the official name for a product. And why do we need official names? Well, one more illustration. What do dimethylmethane and propyl hydride have in common? They are both legitimate names for propane. And it gets worse. These are all synonyms for what product? Rubbing alcohol. Now, something simple as rubbing alcohol can have 8 other names. We could be in trouble. So unless we had some official names, the potential range of names becomes overwhelming. Now, there are several rules concerning how you use and write down the official shipping names. First, the regulations do recognize that sometimes 2 names are allowable. In such cases, Schedule 1 separates the 2 names by the word or. For example, both acetic acid glacial and acetic acid solution are legitimate names for acetic acid, more commonly called vinegar, which is not an allowable name. As there are many more products and combinations of products than the regulations can possibly list, the regulation create groups of products with the same hazards. An example is flammable liquids. While the regulations do explicitly list gasoline, ethanol, and several other flammable liquids, that leaves tens of thousands unlisted. So the regulations include the category flammable liquid not otherwise specified, where the acronym NOS means not otherwise specified. This is the catch-all shipping name for all flammable liquids that are not explicitly listed in Schedule 1. There are dozens of such categories throughout the schedule. There are several more shipping name rules to cover. Shipping names may be singular or plural, so battery and batteries are both allowed. The names may be written in upper or lower case. An exception to this is when there's some descriptive text after the name. Here we have sodium chloride, commonly called bleach. Sodium chloride comes in many strengths, only the strongest of which are dangerous. Thus we have the descriptive text, sodium chloride with more than 7% available chlorine. When the name is followed by descriptive text, the shipping name must be in uppercase letters, and the descriptive text must be in lowercase letters. The shipping name may be written in English or French. Question: what do non-English or French-speaking emergency crews do if they cannot read the shipping name? Well, as we mentioned, they use the symbols and the UN numbers as discussed earlier, as the UN number is universal and does not depend upon a language. The words in the shipping name may be put in a different order, as long as the full name is used and the word order is a commonly used one. For example, ammonia anhydrous may be rewritten as anhydrous ammonia, where anhydrous simply means that it does not contain water. For solutions and mixtures, one writes the shipping name followed by the words solution or mixture, and may include the concentration of the solution or mixture. For example, ethylene oxide and carbon dioxide mixture with more than 87% ethylene oxide, as illustrated on the slide. Here, ethylene oxide is a gas used to sterilize hospital equipment. For waste, the shipping name is preceded or followed by the word waste. For example, the oily rags you throw out in the bin are officially called cotton waste oily. Our last shipping name rule is used when a dangerous good is mixed with non-dangerous goods. If the mixture or solution is named in Schedule 1, you use that name. For example, a mixture of 30% ethanol and water would be called ethanol with more than 24% ethanol by volume. If the dangerous goods are not listed explicitly in Schedule 1, use the dangerous goods' original shipping name along with the description. For example, a solution of mercuric chloride dissolved in water would be classified as mercuric chloride solution, X% mercuric chloride by weight. And to everyone's great joy, that ends our discussion of shipping name rules. Getting back to our original aim of talking about the parts of Schedule 1, the next column is the class. Very similar to WHMIS, transportation of dangerous goods groups products into classes with similar hazards, such as explosive, toxic, etc. Most but not all classes also have divisions, which are essentially subgroups or finer groupings of products. A class may be 1 digit for the class alone, or 2 digits for a class and a division. For example, class 6.1 is class 6, division 1. Any subsidiary class is shown in parentheses below the primary class in Schedule 1. For example, here you see methanol, which has a primary class of 3 and a subsidiary class of 6.1. Following the class column is the packing group column. Now, the packing group has very little to do with how you pack things. It is, in fact, a degree of danger classification. Here, packing group 1 indicates great danger. Packing group 2 indicates medium danger. Packing group 3 indicates minor danger. You may notice that class 2 gases and class 7 radioactive materials do not have packing groups. One point to remember, the packing groups are identified by Roman numerals to differentiate them from the UN number, which uses Arabic numerals. After packing group, we have a column for special provisions. These are extra rules that must be followed. They are referenced by number in column 5 of Schedule 1, but the details are actually found in Schedule 2. Question: there are a lot of rules in the regulations. If there's a conflict between a special provision and other provisions in the regulations, which one wins? The special provision takes priority over any other part of the regulations. Now let's look at an example of a special provision. Under column 5 for methanol lists 43 as a special provision. So what does special provision 43 say? It says, in very legalistic language, despite section 2.1 of part 2 classification, these dangerous goods are assigned to this classification based on human experience. And you see listed there, highlighted on the slide, UN 1230, which is the UN number for methanol. Put in plain English, this means even though methanol does not meet the criteria for being in class 6.1 toxic, we are putting it there anyway. So what's so special about methanol? As you may know from old moonshine movies, it can cause blindness. But blindness is not a criteria for toxic products. To overcome that, Special Provision 43 puts methanol in class 6.1 anyway, despite the fact that if you use the actual criteria, it should not be there. Schedules 1 and 3 often include the word forbidden at various places. When the word forbidden is shown in column 3 of Schedule 1 or column 2 of Schedule 3, you cannot transport it. For example, dichloromethyl ether cannot be transported by any means. As well, something with no UN number at all cannot be transported by any means. When the word forbidden is shown in column 8 or 9 of Schedule 1, it means you cannot transport it by that mode. For example, allylamine on the bottom row cannot be transported by passenger carrying vessel, as indicated by column 8, or passenger carrying road or rail vehicles, as indicated by column 9. The rules are a bit easier for allylacetate. While it still cannot be transported by passenger carrying vessels, it can be transported by passenger carrying road or rail vehicles. You'll notice that column 9 for alloy alcohol contains a value 1 liter. What does that mean? Values in column 8 and 9 indicate the maximum amount of a product that can be transported in a single container. If a cell in column 8 or 9 is empty, it means there is no limit. For example, we can transport containers of any size on a passenger carrying vessel. However, we are limited to container sizes of 1 liter for passenger carrying road or rail vehicles when dealing with methanol. A question now. If you cannot transport allylamine by passenger carrying ships, trucks, or rail cars, how can I move it? A very simple method: don't carry passengers. The regulations do not say it cannot be transported by a vessel. It just says it can't be transported by a passenger carrying vessel. Given all these classification rules, who's responsible for classification? In WHMIS, it is the manufacturer. But in the transportation of dangerous goods, it is the consignor, the person who ships the product. That may be a middleman, not the manufacturer. So where can you get the proper shipping names and classifications? In most cases, a non-manufacturer will look at section 14 of the safety data sheets, and presto, there in the transportation of dangerous goods information. In a lot of cases, similar information will be listed more than once. In the case shown on the slide here for acetone, similar information is listed 4 times. Because the classifications, although very, very similar, are not exactly the same for all modes of transportation. So here they list the rules for the U.S. Department of Transportation, DOT, the U.S. rules for road and rail, the Canadian Transportation of Dangerous Goods Regulations rules, the International Air Traffic Association, IATA, rules for aircraft, and finally, the International Code for Maritime Transport of Dangerous Goods, IMDG code for ships. In this case, all 4 use the same classification. But as I said, in rare cases, they may differ. Beyond using safety data sheets for the transportation of dangerous goods information, I want to give you an idea of how classification using the criteria actually works. For example, let's take sodium cyanide, a common product used in gold refining. Cyanide is solid, non-explosive, non-combustible, toxic, not radioactive, not corrosive, not infectious, not an oxidizer, and does not bioaccumulate. Now thinking of our classifications. Non-explosive means it is not class 1. The fact it is solid means it cannot be either class 2 or 3, which deal with gases and liquids. The fact it is non-combustible means it is not class 4. The fact that it is not an oxidizer means it's not class 5. What about class 6? Well, we do not have enough information to automatically eliminate it from class 6.1 toxic. But the fact it is not infectious means it is not 6.2, an infectious material. The fact that it's neither radioactive nor corrosive means it's neither class 7 or 8. Lastly, the fact that it does not bioaccumulate and is not a marine pollutant means it is not class 9. So we're left with looking in detail at class 6.1. The criteria for class 6.1 are based largely on LD50, the dose required to kill 50% of the test animals. And where do we get that information? Again, looking at the safety data sheet, this time section 11. The slide shows an excerpt from this sodium cyanide safety data sheet. The criteria for class 6.1 are 1, an oral LD50, that is given by mouth, of less than or equal to 300 milligrams per kilogram. Sodium cyanide's value of 5.733 milligrams per kilogram, so it meets the criteria. The LD50 dermal, that is applied to the skin, of less than or equal to 1,000 milligrams per kilogram. Sodium cyanide's value of 14.602, and so it also meets that criteria. So sodium cyanide meets the criteria for a toxic product. Are we done? No, we still need to determine the packing group. Criteria for packing group 1 are an LD50 oral that is less than 5, LD50 dermal that is less than 50. Sodium cyanide's oral LD50 is 5.7, is too high for this packing group. However, its dermal LD50 is well within range. As we always take the lower packing group, we classify sodium cyanide in packing group 1. And our final conclusion? Sodium cyanide is class 6.1, packing group 1. And is this right? Well, Schedule 1 agrees with us. What do you know? Column 3, class 6.1, column 4, packing group 1. And that just leaves one more item to discuss when it comes to classification. What do you do if you have a product that falls into more than one classification? For example, see the methanol entry on the slide. We know from our rules that the primary class is 3 because it is not in brackets. But why is 3 the primary class? The basic rule is that for dangerous goods that fall into more than one class, like methanol, the class deemed most dangerous is the primary class. All of the classes are subsidiary classes. But that still doesn't answer the question about how you determine which class is most dangerous. Basically, there are two ways. For gases in class 2, there is a set priority shown on the slide. Class 2.3 toxic gas is the most dangerous, followed by 2.1 flammable gas, and lastly 2.2 non-flammable and non-toxic gas. For example, take arsine, a gas formed by mixing arsenic with acid. It is both toxic and flammable, classes 2.3 and 2.1. Since 2.3 is higher than 2.1 on our list, 2.3 is the primary class. That's okay for gases, but what about our methanol, which is a liquid? For liquids and solids, the regulations have a table of precedence, which tells you the primary class for any combination. Thinking back to methanol, we have class 3 packing group 1 and class 6.1 with no defined packing group. Looking at the left-hand column on the slide, we find 3.1 packing group 1 right at the top. Moving over to the right, we look under the class 6.1 column to find the cells circled in red. For all packing groups, class 3 is the primary class and 6.1 is the subsidiary class. And that yields the entry that we see in Schedule 1. And that concludes our discussion of the classification of dangerous goods and the use of Schedule 1. I invite you now to move on to Module 3, where we will discuss some exemptions to various parts of the transportation of dangerous goods regulations.